Now this illustration deals with 3 or more current carrying conductors and a raceway or cable in accordance with 310.15 C as in car 1. Now before we get into this illustration in more detail, let's review the note 1 at the left-hand top side of the illustration. And the note just plainly says C240.4D, which limits the size overcurrent protection device to 15 amps for number 14, 20 amps for number 12, and 30 amps for a number 10 AWG, say, copper conductor. Now note 2 sends a warning. Each current carrying conductor of a parallel set, like L1, L2, or L3, each phase, if they are current carrying, they have to be counted as such if they fall within the rules of our table 310.15 C1. Now, notice in the boxed in information where it has quick calc 1, notice this was the, exactly what the test taker would do if they should ask what is the short time current rating of a conductor. Now notice the short time current rating is equal to the circular mil of a number 12 AWG wire divided by 42.3. Now the second bullet in the boxed in information, we would really refer to table 8 to chapter 9, and our number 12 conductor has a 6,530 circular mil area. So as a rule of thumb, dividing it by 42.3, the short time current rating now for 5 seconds is 154 amp. Now sometimes on the test they'll want to know what is the short time current rating of a conductor that has a current limiting fuse connected ahead of the conductors. Then we'd go to quick calc 2. Now notice we would take in the square root the current squared times the clearing time of 5 seconds divided by the new clearing time, 0.0084 seconds. Now sometimes test takers want to know how was the 0.0084 seconds obtained. Well, we would take, say, one half clearing time of a time delay fuse times 0.0167, and that's how we would obtain the 0.0084 seconds clearing time. Now when we do our math in the second bullet by taking 154 amps times 154 amps times 5 seconds now, divided by the new clearing time of 0.0084 second, then we come up with a short time current rating of 3,757 amps. So remember how to calculate, in other words, if the examination doesn't call for a certain quarter, half, or 2 cycle clearing time, then we would use the calc 1. But if we should have a time delay fuse or a clearing device of a quarter or a half cycle or 2 cycles, just remember you can take 0.0084 seconds, and it's obtained by taking a half cycle times 0.0167. Now let's look at the boxed in information for 3 current carrying conductors. Now if you were using the 2017 code, we'd be applying 310.15 B3A for these 3 conductors. But since you're taking your test on the 2020, step 1, we would use table 310.16 and a number 12 THWN copper conductor in the 90-degree column is 30 amps. We only use the 90-degree column when we're derating for adjustment or correction factors. Now, step 2, we have correction factors in accordance with 310.15C1 and Table 310.15C1. And since there's only 3 current carrying conductors, then step 3 takes 30 amps at 100%. And that conductor really has a long time current rating of 30 amps. But as you see in the solution and the answer, 240.4D, as you see in note 1 above, would limit it to 20 amps at number 12 because of the 20 amp overcurrent device being placed ahead of the number 12 copper conductors. Now moving over to the second boxed in information to the right, again, the 2017 code, you'd be applying 310.15B3A. But we're applying step 1 and the 2020 NEC, which is table 310.15C1. And we have 4 conductors that are current carrying. And our table 310.15C1 requires an 80% reduction of the ampacity. So in this case, step 2, we apply the table, and 30 amps times 80% would be 24 amps. Now the 80% is based upon 4 to 6 current carrying conductors and a raceway or cable. Step 3, the table 310.15C1 has been applied in step 2. So now we'll apply 240.4D. We'll take 100% of 24 amps, which is 24 amps is what the conductor is good for. But due to 240.4D and the solution and answer, then the number 12 is limited to 20 amps based upon the 20 amp overcurrent device required for number 12 wire is outlined in 240.4D as in dog. So that's what our figure 4-1 is illustrating to us and making clear how we could figure 3 or less current carrying conductors, the ampacity, 4 more current carrying conductors, what the ampacity would be, the short time current rating, and the long time current rating of a conductor.